Today, we're going to start looking at matrix operations or working with matrices. Matrices are just a way to help us organize information. A capital letter is used to refer to an entire matrix. The matrix shown to the right over here can be referred to as matrix A or just simply A. A specific element in our matrix can be referred to using subscripts to indicate the rows and columns where the element is located. So our rows are always going to be here to the left, and then columns are up and down. In general, for an example, we have A, HK. So talking about this one right here would mean that it's in row H and column K. So in number one, in matrix C, the entries are the numbers of students on a committee. Column 1 represents girls, so columns are up and down. Column 1 represents girls. Column 2 represents boys, just labeling here for us to reference. And then our rows from the sides, we have sophomores in row 1 and juniors in row 2. We're going to find A12, A21, and A22 and tell what each number represents. So let's start with A sub 1, 2. That is going to be row 1, column 2. So in the context of our problem, we are looking at row 1, column 2 is going to be right here. That 5 is 5 boys, 5 sophomore boys. Let's look at A sub 2, 1. So row 2, the juniors, column 1, we're looking at that 8. That is going to represent 8 junior girls. Let's look at A sub 2, 2. Row 2, column 2 is going to be the juniors and the boys. This 10 here, so we have 10 junior boys. Next in our notes, we're going to look at scalar multiplication is multiplication of each element in our matrix by a single real number called a scalar. So in matrix C, shown to the right, the columns represent the brands vintage, casual, and distressed, and then the rows represent jeans and jackets. If the sales tax rate is 5%, find the sales tax amount for each item, or find 5% of each price here. These look like some really expensive jeans and jackets here. So let's do sales tax rate. We're going to do 5% times matrix C, or that would be 0.05 times that whole matrix. 320, 210, 160, 240, 110, and 65. So we're going to multiply each element by that number. I'm going to show that just here in our notes. We're going to do 0.05 times the 320, 0.05 times 210, 0.05 times 160, 0.05 times 240, 0.05 times the 110. You see, yes, 0.05 times the 65. Okay, so this is scalar multiplication. We're just multiplying one value by every element. So you could use your calculator. Multiplying the first term, we get 16. The 0.05 times 320 is 16. Next element is 1050. When I multiply 210 times the 5%. When I do 160 times 5%, we get 8. In our next row, 240 times the 5% gives us 12. And just use my calculator on this. 5% times the 110 is 550. And then our last element in our matrix, the 5% times the 65 is $3.25. So that would be the sales tax for each of these jeans and jackets from the brands vintage, casual, and distressed when the sales tax rate is 5%. So just scalar multiplication, multiply the number by every element to change your matrix. Adding and subtracting matrices involves adding or subtracting those corresponding pairs of elements. To have corresponding pairs of elements, your matrices must have the same dimensions, so same rows, same columns. So our example continuing here, Cool Threads uses matrices to keep track of those monthly sales. In matrix A and B, row 1 represents the jeans, row 2 represents the jackets, and with columns representing those vintage, casual, and distressed brands, respectively, during 2 consecutive months. So notice in both of these matrices, this is considered a 2x3 matrix, and this is also a 2x3 matrix. We always talk about our rows times or by our columns. So there's 2 rows, 3 columns, and same on matrix B, it's 2 rows and 3 columns. So they have to be the same because we're going to add or subtract each element. So everybody's got to pair up somehow. Number 3, what would be the sales total for the 2 months? So let's do A plus B. I'm going to show this all out. We're going to do 14, 11, 28, 10, 15, 35. Matrix A plus matrix B. 18, 17, 25, 16, 9, and 45. So just to illustrate, we're doing 14 plus 18. The element that's in 1, 1, first row, first column is going to get added together. 11 plus 17, 28 plus 25, 10 plus 16, 15 plus 9, and 35 plus 45, giving us our new matrix for this addition. It will also be a 2x3, 2 rows, 3 columns. Adding those with my calculator, I'm getting 32, 28, 53 in my first row, second row 26, 24, and 18 is our final matrix to show the total for those 2 months. Number 4, what would be the difference in the number of items sold each month? So just illustrating, we can do subtraction here, A minus B. So 14, 11, 28, 10, 15, 35 minus the B matrix, 18, 17, 25, 16, 9, and 45. When we subtract those, I'm getting a negative 4. 14 minus 18, negative 4, negative 6, 3, negative 6, 6, and negative 10. Just subtracting those corresponding elements. On our second page of our notes, we're going to kind of put everything together. Number 5, given the matrices A and B shown below, we're going to find A plus 4 times B. All right, so let's go ahead and do the scalar multiplication. We're going to multiply everything in B by 4. So I'm going to go ahead and fill that in a little bit here. I'm going to go ahead and write my A matrix. We're going to have A plus our new B here after we multiply it by 4. So 4 times 5 is 20. 4 times 4 is 16. Negative 12, negative 24, positive 24, and negative 4 would be our new B that we're going to add with it. Final answer, when we get those added together, is going to give us 18, 18, negative 8, negative 23, 20, and negative 4. Okay, so we had A plus 4B. Went ahead and did that scalar multiplication first, the 4 times the B matrix, just multiplying every element by 4. And then we finished with that addition, adding those together, the A matrix with that new B matrix after the scalar multiplication. Number 6, we're going to find negative 4A minus 6B. You can see that this matrix is a 1x3. So let's go ahead and set it up. We're going to do negative 4 times this A matrix and negative 6 times this this B matrix. And I'm going to go ahead, I'm going to multiply with negative 6 so then I can just add my matrices together. Okay, so the new A is going to be positive 16, negative 24, and then another positive 16. Multiplying with that negative gives me a positive 6, another positive 6, and negative 12. So then our final answer Adding these matrices together, we're going to have 22, negative 18, and 12 as our final answer. Number 7, given the matrices A and B shown below, we're going to do B plus 1/2 A. So B is going first. We have negative 5, 9, 8, 9, negative 7, and negative 2. B plus 1/2, 0, 0, negative 10. All right, so let's multiply that through. Still leaving B the way it was. When I multiply with that scalar, the 1/2, our new matrix is still 0, 3, 0, negative 1, negative 5, and 6. Multiplying by 1/2 there, and then we just need to add them together. Final answer for B plus 1/2 A is negative 5, 12, 8, 8, negative 12, and 4. Just adding those corresponding elements together after our scalar multiplication. Number 8, given A and B, we're going to find negative 1/4 A plus B. So again, we're going to multiply A by our scalar here. Little baby matrix here. 1/4 of 4 would be a negative 1. When we multiply there, negative 1/4 times negative 16 is going to give us positive 4. And then we just need to add it with B, which is 2, 8. Adding those corresponding elements, negative 1 plus 2 is 1. And then we have 12. 1, 12. So starting off our matrix operations here, getting familiar with the rows and columns, and we're going to talk more about dimensions as well, but we always name our matrices by rows and then columns, and I always do that in my head. I'm like, to the side, how many rows do I have? 2 or 3 or 1? Or so it's rows and then columns is how we name the dimensions of our matrices. And then we can apply scalar multiplication, which is just multiplying the entire matrix by a single number. And then we also looked at how to do adding and subtracting. Obviously, we then can combine those like we saw in examples 5, 6, 7, and 8. Guys, let me know if you have any questions, and we'll move on with more matrices in our next lesson. See you in class.